Hey guys, welcome to ByteBay. I know it probably feels like an eternity since the last ByteBay video was published. It has been a long wait with no sight of any new video for days, but now that the video is here, I hope I am welcomed with open arms. Today let's understand the difference between two very key concepts in software systems, latency and response time. In software system design, we frequently encounter the words latency and response time, and oftentimes people use these terms interchangeably, but even though sometimes they may appear similar, they are actually very different. When analyzing input and output performance, it is important to differentiate the true meaning of each term so we know how they are affecting the overall performance. Because if we don't know what we are dealing with, we won't know what it can do to the system. So let's just get our shit together for a few minutes to understand and compare these concepts. First, what is latency? Latency is the time it takes for data to pass from one point on a network to another. Suppose a user in London sends a data packet to server in Paris. Say it takes 89 milliseconds for the request to travel, then 89 milliseconds is the latency for making the request from London to Paris. Next, what is response time? Okay, this one will take some time, so pay attention. Suppose it's Pizza Friday and you want to order a pizza. So you place an order, the pizza house receives the order, they forward the request to the chef in the kitchen, the pizza is ready, it is sent for packaging and then sent to your home. In all this, the time it took for order to be received by the pizza house is trip 1 latency. The time it took to deliver the pizza is the trip 2 latency. And the time it took to make the pizza is the processing time. So the response time here is the sum of the trip 1 latency, trip 2 latency, and the processing time. But the question remains, what causes high latency and response times? Well, a real-world system is much complex than ordering a pizza. There is usually a browser or a client sending requests to some domain, the IP of which, if not found in the browser or system cache, will be looked up from the internet service provider. If not found there, it will be queried from the root domain name server, which will serve the response back to the ISP, which in turn responds to the client, which finally sends the request to the domain for which the request passes through a mesh of connected routers, eventually reaching an API gateway which lets the request to a load balancer probably, finally reaching the server, but even then it may need to talk to a database or a third-party API, and this is just a simplistic representation. The time taken for communication between each of these points is the latency between those points. The time taken to process the request at each of these points is the processing time at those points. So the total response time is the sum of all those times, that is the latency and the processing time. So you can see that the total time taken to process a simple request in a real world is the sum of all the time taken to hop from one device in the network to another and the processing delays at each and every device in that network. So something that seems like a simple request from a client to a server and back is actually an extremely complex network path undergoing a lot of computations. The value of this time has to do a lot with the physical distance between computers, the bandwidth, and the connection quality. So next time you grow old waiting for the page to load, blame latency and the long response times. But wait, there is one more thing that is making life tough for us. Going back to our original pizza example, if the orders arrive one by one after the previous order is processed, then well and good. But imagine tons of orders arriving at the same time. If your kitchen can only make 2 pizzas at a time, the new orders will have to wait before processing of older orders is complete. On top of that, when these orders are waiting to be processed, even more orders may arrive and wait in queue. This is called queuing. This exponentially increases the latency and is one of the actual reasons which causes high latency, which means latency includes the duration that a request is waiting to be handled, during which it is latent or awaiting service. So the response time is the sum of traveling time plus the waiting time plus the processing time, where everything excluding the processing time is latency and the waiting time in it being the time spent on queuing. Similarly, when it comes to processing, we can't say that processing has started if the order is about to be received, or say it has started processing if the order is like this or like this. We can only say processing has started if the order is completely received like this. So what does that mean in software systems? It means the input TCP packet containing the data has to be fully received by the processing system in order to mark the time when the processing starts. And similarly, the output TCP packet has to be fully sent out from the processing system in order to mark the time when the processing has ended. So till the time TCP packet is out of the server, the time spent is considered part of latency. Once the packet is inside, the time spent is part of processing. Overall, they both add up and contribute to the response time. Okay, but how does one measure this? Response times are represented in terms of percentiles, usually by terms like P99 and P95, which basically means if we are saying P99 is 3 seconds, then 99% of requests were faster than 3 seconds and 1% of the requests took 3 or more seconds. But if you are interested in ways to troubleshoot and log response times and latencies in system, there are more sophisticated ways and tools available to achieve that. Chrome's Dev Toolbar is a good place to start. That's it for today, folks. If you like this content, please like the video and subscribe to the channel. That would motivate me to make more videos like this. Till then, see you all.